Hello, welcome to Future Genius. Today we discuss about the federated learning based concept for model training on diabetes dataset.
So let's first have a look at the dataset. This dataset I have downloaded from Kaggle, which is a diabetes dataset including business columns. You can see here, and our final result is the outcome. Is the person does the person have the diabetes or not, which is a binary classification problem. So what I have done here is I have divided this entire dataset into three small datasets to simulate three different hospitals' data. So federated learning is basically used for privacy preserving model training. All these three hospitals were trained on the data locally and then only share the weights and biases with the server. So first let's have a look at the server. Um, First we have declared a class that is fed server, which we can say federated server. In the edit method, we are just providing the number of rounds and evaluation results, which would be accuracy and loss. So the get evaluate function would be called by the federated framework, Flower framework that we are using here, and which would call the evaluate method inside it. And what we are doing over here is if we have not uh, got the results from the client, then we would print that no results, no evaluation results are available, and then we would append 0 with accuracy. And if we did get the result from the client, then we would call the aggregate evaluate metrics on that particular evaluation results. Uh, let's just first finish this function. So the average loss is calculated using the it would be extracted from these aggregated metrics, and the accuracy would also be extracted from that. And then we are just returning the loss and accuracy. Um, Fit config is basically providing the configuration details to the client, like the number of epochs is 5. So the client would train for 5 epochs and batch size would be 32 to have a uniform training approach across all clients. Similarly, there is evaluate config, so the all clients are evaluated properly. Let's now have a look at the aggregate evaluate metrics function. First, we are getting the evaluation metrics that we pass from the above function, and then initializing the loss accuracy and examples to some default values, which is blank and 0. Then for each entry in the evaluation matrix, we would see that the total number of entries is 2. Then we uh, we interpret that the loss is not provided, so we assign a default value of 0 to the loss. And if the length is 3, all the values are provided correctly, so we uh, assign the values properly. Otherwise, if nothing is provided, then we skip that entry. And then we are just appending the weighted loss, which would be based on the number of examples per that client. So it is a common knowledge that the client with more data and more examples would have more greater impact on the accuracy and loss. So similarly, the weighted accuracy is calculated for the global model, and both of those are then it is the simple average is taken of all weighted accuracies, and then they are printed for each round. The start server function would start the FL server. The strategy that we have provided is federated average. So this would average the weights and bias that we have received across all clients. Minimum fit client is 3 and minimum evaluate client is 3. So uh, at least 3 clients are required to start the server. And these 3 lines mean that thing. And then we have provided the evaluate function and the on-fit config function and evaluate function and matrix aggregation function. Then we are just starting the server on localhost 8080 and server config. We are providing the number of rounds for which the server would train. So we have provided here 12 rounds in the main method, and above we had provided 5 default values for the number of rounds. Now let's have a look at the client part. So the client part, we have the FNN, which is the feed-forward neural network, which can be used for binary classification. Inside the neural network, we have the first hidden layer, which would be of 64 neurons. So this hidden layer would be mapped by the input dimension, which would be the total number of attributes in our data set after removing the target attribute. Then the ReLU activation function is applied on that, which would be maximum of 0, comma x. So if a negative value is provided, you take consider it 0. Then a dropout is provided of 0.2, which is 20% to prevent the model from overfitting. Then the layer 2 is of 32 neurons, similarly ReLU and dropout. And then the output is of one neuron only, as it is a binary classification, and the sigmoid is applied at the output. Then in the forward method, we are applying all these things to our data. Then a federated client class is defined, in which we are taking the CSV part of the data set. So we would train it like Python client.py, and then the CSV part like client one.csv. So this is how we are going to execute this. Okay. Uh, so the CSV part is provided. Then the device is provided so that if there is a GPU available in the PyTorch, then it can use it. Then the model and train test data and everything is initially provided none value. Now let us come to the load dataset part. We just loads the dataset which is provided in the CSV part, and then reads the column, drops the outcome, which is the final variable x and y, and then train and test variables are taken out. Test size is 0.2, so it would be 80-20 split. So then standard scaling and all those methods are applied. BC loss is calculated, which is the binary cross entropy loss, which is what uh, binary classification task. Then there is Adam optimizer, which is adaptive optimizer for adjusting the learning rate. So this would adjust the learning rate accordingly. The get parameters and set parameters methods are provided to get the parameters from the server and uh, provide the parameters to the server. Then the fit method is defined to fit the model with the provided data. So the train data set is provided, and the data is loaded according to the batch size, and shuffle is true. So we are not training the data on majority of same values. And for each epoch, it will train the model, and the loss is calculated accordingly, and the model is evaluated. Okay, we are also calculating the local accuracy for each model. This accuracy would be coming from this evaluate method, which evaluates the model's performance for each round. And then there is the main method in which the arg parse is used so that we can provide the CSV files as command line arguments, and those files are extracted as arguments, and the federated client is initialized using the CSV part. And we are providing here that the server is running on the localhost 8080. So it knows where to send the data. Now, let us try to execute this and have a look at how our model is preparing, uh, how it is working. So first, we would have to run this server. Okay, so the server started. Now let's train the client. So what I've done here is client one and get a CSV of text client, then the ampersand, then second, and the third one, so that all the clients can start simultaneously. Okay, so it would go on for 12 rounds, and then we can see that the local model accuracy we can see here is 99.6 for the first client, and 99.3 for the second, and 99.2 for the third client. Similarly, we can see the loss for each client and at each round. This is for the round 12. Then we can see the global model performance as well in terms of accuracy. It is performance of around 99, which is a good performance, which is actually a very good performance given the nature of the federated learning approach. So it is a good data set, which is why we got this much high accuracy. And certainly we do not get this much high accuracy in federated learning framework. So this was how federated learning is used to predict binary classification in diabetes dataset. One more thing is that here we are just simulating the federated learning environment using the multi-threading approach where we are creating multiple threads of the client. So in the real world, the server would be stored somewhere else and the client would be stored some at their own local places. So and there this framework is majorly used. And we can say it is privacy preserving framework as the hospitals does not need to share their patient data and just share the weights and bias of their model and train their global model together.
Thanks for watching.